Okay, students, on this group we're going to be getting ready for the Unit 4, Unit 5 tests. So, right on the title of this lesson, um, review for Unit 5 test. Okay, so let's draw the first number, question number 1. This matches with number 1 on your packet. We are asked to find the first 5 terms of the sequence a sub n equals n minus 6. So basically, for this one, since you're looking at the first 5 terms, we're just going to be plugging in n equals 1 all the way to 5. So for n equals 1, that's basically a1. We're going to plug in, we're going to do 1 minus 6, which is negative 5. And for a2, n is basically 2. We're going to substitute 2 in the equation, 2 minus 6, which is negative 4. A3 is basically the third term, which is what you get when you have n equals 3. And that's 3 minus 6, negative 3. A4 is 4 minus 6, which is negative 2. You can see a pattern. It keeps decreasing by 1, right? I'm sorry, it keeps increasing by 1. And then A5, you can guess what A5 is. It's going to be negative 1. So your final answer is the sequence negative 5, negative 4, negative 3, negative 2, comma, negative 1. Alright, and that corresponds to letter A. Alright, let's move along to the next set of problems, which is creating an explicit rule. We're going to take a look at number 5. We want to create an explicit rule. I want to create an explicit rule for the sequence negative 3, 0, 3, 6, and goes on and on. Okay, so basically when you're creating an explicit rule, you're looking for the rule for the nth term, so you're going to be making use of the formula a sub n equals a1 plus n minus 1 times the common difference d. All right, so in this case, let's see if we have a1, n, and d. So basically, if you look at this formula, a1 is the first term. A1 is equal to negative 3. N is the number of terms. Since it's the nth term, we just remain as n. The common difference is what you get when you subtract a2 from a1 or a3 from a2. So a term subtracted by the term before it will give you the common difference. So in this case, you're going to do 0 minus negative 3. So you got to be careful with the sign. In this case, you're going to have 4. I'm sorry, you're going to have 3. Okay? So 0 minus negative 3 is positive 3 because minus times minus is a plus. So you're going to have positive 3. Alright, so we're going to plug in these 3 arguments into this, these 3 values into this equation that will generate our explicit rule. So a sub n is going to be the first term, which is negative 3 plus n minus 1 times the common difference, which is 3. You can rewrite this as negative 3 plus 3 times n minus 1. Okay? And your answer for this question is going to be B. Alright, let's move along to the next set of problems. Question number 6. No, I'm not going to do 6. Let me go to the next set. So the next set, we're going to do question number 10. So for number 10, we're going to find the explicit rule for the nth term of a sequence. In this case, it's a geometric sequence. So for number 10, we have 9, 18, 36, 72. We know that this is not a geometric sequence, arithmetic, because if we keep adding 9 every time, this next number is supposed to be 27, and it's not, it's 36, so it indicates that we are multiplying by something every time. Alright, so this is a geometric sequence. So the formula that applies to geometric sequence is basically a sub n equals a1 times r to the n minus 1. Okay, so that's basically what the formula is. All right, so let's go ahead and see what we know. We know that A1 is the first term. This is A1 right here, 9. R is a common ratio which we derive by dividing a term by the term before it, like A2 over A1 or A3 over A2. Doesn't make any difference. So 18 over 9 is equal to 2. So A sub n is equal to the first term, which is 9, times the common ratio, which is 2, raised to the n minus 1. Okay? So there goes your final answer, and the answer to this is C. I'm sorry, it's D. D is the answer because it's switched around. So let's be careful here. The answer is D. Alright, now let's move along to the next set of problems. Sum, number 15, it says find the sum of the arithmetic series. So find the sum of the arithmetic series, actual sequence. Alright, so we have -8, -5, -2, 1, 4, 7, 10. So for this one, we're going to use the formula Sn equals n over 2 times a1 plus an. Okay? So if you look at this problem, n is the number of terms, a1 is the first term, an is the last term. So how many terms are there? 1, 2, 3, 4, 5, 6, 7. So there are 7 terms. The first term is -8. The last term, a sub n, is 10. So to generate the sum, we're going to apply this formula. S sub 7 is going to be 7 over 2 times -8 plus 10. Okay? Alright, so for this one, we're going to have 7 over 2 times, if you do that, it's 2 over 1. And then you're going to have 14 over 2. Final answer is 7. Alright? Now, if you take a look at questions like number 19, you're missing n. So you need to use the other formula, an equals a1 plus n minus 1d, to find what n is first before you can use this formula. Okay? So that's how those problems work. All right. Let's move on to the next example. All right, we're going to move on to question number 20. So on question 20, we're looking for the sum of a geometric series. So we have 2, 4, 8, 16, 32. So the sum of geometric series is given by the formula S sub n equals a1 minus a1 r to the n over 1 minus r. Okay, so in this case, a1 is 2. R is a2 divided by a1, which is 4 over 2, which is 2. And then n is the number of terms, 1, 2, 3, 4, 5, n equals 5. Alright, so to compute the sum, we add in the first 5, so s of 5 is going to be 2 minus 2 times 2 to the 5th over 1 minus 2. Alright, so that's going to yield 2 minus 2 to the 6th over -1. Alright, so it's going to be 2 minus 2 to the 6th is 64 over -1. So your final answer is going to be simply 62. Alright, so your answer is B. Alright, let's move on to the next example. Question number 25. We're going to be finding a limit here. So 25. So let's find the limit algebraically. So we're going to do limit as x approaches 1 of x to the 4th minus 1 over x minus 1. So So the fact we can, if we plug in 1, we're going to have, if we plug in 1 directly, we're going to have 1 to the 4th minus 1 over 1 minus 1, which is going to give us 0 over 0, which is undefined. So since this is undefined, we have to factor it, all right? So how do we factor this? So x to the 4th minus 1 needs to be factored, all right? So what's the factor form of x to the 4th minus 1? It's going to be x squared minus 1 times x squared minus 1. And then it factors further into, okay, this is a plus over x minus 1. And then we can factor the minus further into x plus 1 times x minus 1 times x squared plus 1, right? That whole thing divided by x plus 1. Remember, it's only the difference that you can factor further, okay? Over x minus 1. All right, so now the x minus 1s cancel out, right? And then you're left with this expression right here. So now we're going to take the limit as x approaches 1 of x plus 1 times x squared plus 1. And then you're going to have plug in 1, you have 1 plus 1 times 1 squared plus 1. And that gives you 2 times 2, because 1 squared is 1, 2 times 2 is just simply 4. So your answer for this choice is D. Okay? Alright, last one we're going to take a look at is number 31. We're going to solve this using direct substitution. So we want to find the limit as x approaches 0 of x squared minus 5. So we plug in 0, we're going to have 0 squared minus 5, which is 0 minus 5. Final answer is negative 5, and your answer is B. Alright, so thanks for paying attention to this presentation. Hopefully this helps you get ready for the test that you're going to be having next class.